In this lecture, which goes along with Chapter 6 in your textbook, I'm going to discuss the importance of sampling and some important aspects you should be aware of. Sampling is not discussed a lot, and it's usually just a small paragraph or so in a research article, but it has huge implications for how much confidence you can have in the results of the study that's being done. Now, keep in mind that I'm discussing quantitative studies. Sampling is a totally different concept in the world of qualitative research. So let's get started. There are three things I want you to take away from this lecture. First, I want you to understand the differences between different sampling techniques, especially the pros and cons of probability sampling and non-probability sampling. Second, I want you to be able to discuss how sampling affects how much confidence we can have in the research and the decisions that we can make about that research. Last, I want you to be able to look for the appropriate pieces in a research article and critique them so that you can be an informed consumer. So let's get started. There are several terms I'm going to be using in this lecture, and you need to understand them so that my discussion makes sense. So I'm going to take a few minutes here to go through some vocabulary. First of all, let's talk about units of study. The unit of study is the smallest component that you're studying. In some research, you're looking at individuals, and you're studying each individual's results. And then these individuals are called participants or subjects. But at other times, you're studying a group, such as a class or a group of teachers or a school or a group of people who attended a professional development, for example, compared to a group that didn't. And so the unit of study can either be an individual or it can be some kind of a group. Now, after you've got units of study, there are units of analysis. So we could study examples, but then compare the aggregated data for those people, such as the average scores per classroom. And then the unit of study is the individuals. You collected data from each individual, but your unit of analysis would be their class. Look for this in research articles. Some researchers are a little careless in saying they are studying individuals, but then as you read, you realize they are analyzing the data at a group level, not at an individual level. Let's talk about a population. A population is the entire group that you are interested in. Some examples might be third grade students, stay-at-home moms, second career military retirees, poodle owners. More specifically, we often use the term target population. This is really the group you want to generalize your results to. So you could think of the population of the United States, but perhaps your target population is people with a high school degree. And so that would be a narrower subgroup of the population. It's best to make your target group population as specific as possible. It's better, for example, to say your target population is third graders in urban schools in the southwestern United States than it is simply to say your target population is third graders. In every study, there's a target population of interest, but the researcher never has access to all of them for a sample. So there's a survey population. That is the group the researcher actually has access to. So if I have a target population of 8th grade English teachers in urban schools in the southwestern United States, but I'm doing research in the Las Vegas area. However, I could have a colleague in Los Angeles and a colleague in Phoenix. So my survey or research population could be 8th grade English teachers in Las Vegas, Los Angeles, and Phoenix. It's a smaller group than the actual target population that I want to generalize to. Now, it's impossible to gather data from an entire research or survey population. So what we do is we collect data from a representative group within the population being studied. And there are different methods for deciding the sample subjects that you're going to use. And these are the sampling techniques I'm going to talk about during this lecture. Think how really important these pieces are. You need to know the target population for the conclusions the researcher makes. You need to know the sampling techniques used to find the sample subjects to represent that target population. So, the researcher starts with a target population of individuals or units. And that's the group or the individuals you want to find out something about. Let's pretend it's third grade students in urban schools. So I've drawn a blue circle around the third grade students in urban schools in the entire population in the United States. Then you determine the survey or research population. In other words, I don't have access to all of the third graders in urban schools in the United States. I have access, hopefully, to third graders in, like, for example, Clark County School District, maybe about 20,000 students. Then, within that target population, I'm going to choose a sample of the research population. In my example, there's no way I'm going to collect data on 20,000 third graders in Clark County School District. So I'm going to choose a representative sample of those students. And always keeping in mind whether my unit of study is a group or individuals. In this case, all these purple dots represent individuals. There's some important reasons for sampling. First of all, it's almost always impractical to collect data on a whole population. It gets expensive and it would take too long to do. Can you imagine the work involved in doing face-to-face observations, for example, with every 10th grade biology teacher in a target population? In addition, it's simply not necessary. With really good sampling, we can be very, very confident that the sample represents the population. So we don't need to gather data from every member of the population. There are also some possibilities of ethical problems if we do try to get data from every member of the population. It's actually called data saturation. In other words, there's a threshold over which you are exposing subjects to unnecessary risk or harm. And I'm not necessarily talking physical harm or risk, but simply consider the classroom disruption if you really tried to gather data from every 10th grade biology student in a population. There is a risk or a harm there involved, and we want to minimize that. So now we're going to talk about some sampling techniques. And I'm going to talk about probability sampling or random sampling first. This is a statistical way of selecting your units of study. And for the rest of the lecture, I'm just going to consider that they're people. So they're individuals or subjects. It means that the researcher sets up at the beginning a probability of each subject being chosen from out of the group. More on this later. There are 4 kinds of random sampling. Simple random sampling, stratified random sampling, cluster sampling, and systematic sampling. So let's start out with random sampling. With random sampling, you decide what the probability will be for selecting each individual. It needs to be truly random. So you have to think of the probability for each subject. For example, if you've got a population of 100 and you need 10 in your sample size, each of those 100 people has a 10% chance of being selected. You don't change that for any individual. It's like rolling the dice, and they have a 10% chance. Now, if you have a population of 100 and you need 50 in your sample size, each subject has a 50-50 chance of being selected or not. And it's going to be truly random. It doesn't mean that it's going to be every other person or every 10th person or anything like that. It is totally random. And you use a computer program to do this because we humans are notorious for being unable to pick random samples of anything. We're just not good at it. Our brains don't like random. The whole purpose of random sampling is to end up with a sample that truly represents your population. So in this case, in my silly little graphic here, you really want your orange circle to represent your blue circle. You're going to use the smaller sample group to make inferences about that larger group. Remember that I talked in an earlier lecture about the importance of variability. You want the variability in your sample to be roughly the same as the variability in your population, and then you can generalize your results out to your population. Now we need to talk about sampling error. There is no way that a random sample could ever be exactly like the population. What you need to worry about is when you cannot say your results represent reality because your sample does not represent the population. So look where I've put my orange circle this time. If I were to use that orange circle of individuals, they obviously wouldn't represent the individuals in the blue circle or my target population. If you had 100 third graders in your research population and you pulled a random sample of 10 and looked at their math scores on a test, then if you pulled a different random sample of 10 students, their scores are going to be a little different than your first group. Then you pull a third random sample, which you would never really do this in research, but those scores are going to be slightly different than the other two groups. We expect this error in how well the sample represents the population. You could, for example, by chance, pull a sample that included mostly disengaged students or a sample that included very few teachers with graduate degrees. It's very unlikely, but there is the possibility that it could happen. So sampling error is we know there's going to be a difference between reality and the results that are only in your sample. Because we know that each sample is going to give us slightly different results, we calculate what's called a margin of error. This is actually a range within which we can be very confident that the results for our population lie. So, if you find an average score of 50 points for my sample, and then I calculate a margin of error to be 2, and you don't need to know how to calculate that margin of error. That's some statistical work that you can learn about in a different class. But if I calculated that to be 2, I report that the average score is 50 points plus or minus 2. That means that I'm very confident that the average score for the population is between 48 and 52. I don't know why my numbers are off there. Sorry on the graphic. You might want to redraw that on your notes. But you've probably heard this sort of thing in the reporting of political polls. You'll hear that so-and-so has 41% of the current vote with a 5% margin of error, meaning that the candidate probably has between 36 and 46% of the voters on his or her side. We also minimize the sampling error by selecting a large sample. And I'm going to talk about this in another lecture here. Imagine the confidence you would have in the results if you selected 99 subjects out of a population of 100. You're going to be very, very confident that your results reflect the reality of the group of 100. Now compare that if you selected only 2 subjects out of a population of 100. You're not going to be nearly as confident that your results represent all 100 people as you could be when you selected 99 of the 100 people. So that's where we're going to go next, talking about sample size.